sides they have. All right, no matter how many sides they have. You guys already know if I'm talking about a triangle, how many degrees in a triangle? 180, right? Anybody know quadrilateral? How many degrees are in every quadrilateral? Okay, that's because you're going to learn that today. And also along with a 6-sided figure, a 20-sided figure. By the time you walk out the door today, I'll throw any sided figure at you and you'll tell me how many degrees are in it. And on the outside of it as well. Before we do that though, let's drop some knowledge here. Let's go over all the polygons. I'll give you the number of sides. Do we know or have we ever heard how many or what the polygon is called? So if I have 3 sides, you better leave if you don't know that, right? Triangle. 4-sided figure, I always get like a rectangle, a square, and you're right, but those are all types of what this unit's called, quadrilaterals. Anything that's got 4 sides, you can at least call it a quadrilateral. All right, don't be shy to show your knowledge. Look, all of us have something that we know too much about. All right, right? Some of you, you may know all of these, and that's fine. Show off be proud. For me, it's state capitals. I know too many state capitals, and who cares, right? Everyone has that little something that they know way too much about, but you don't want to show it off in front of people. 5 sides. 5 sides. Pentagon. Six. Hexagon. Ooh, now it starts getting a little slower. 7. There's actually 2 names that it's referred to by. Nothing, huh? 7. Going. Going. Septagon. If anybody also was thinking heptagon, that is the other name for a 7-sided figure. Septagon and heptagon. 8, and no, I will not accept stop sign. Octagon, all right. Octagon, we know some of that. Ooh, now we're getting deep. 9, my personal favorite. 9. Na. Yep, nonagon. Good, nonagon. And this is all fun and games now, but you are responsible for these names. 10. 10 years is what? A decade. So this is a decagon.
Okay,
yep.
I was right.
I did skip over 11 because you're not responsible for it, but if you do want to impress people, it's called an unagon. 11 sides. But what about 12 now? 12. Yes, Bailey?
Dodecagon?
Dodecagon. Look at that. Dodecagon.
Oh, why I know that.
Hey, people know the strange facts, right?
Wow, thanks.
The other night in the car, my one daughter busted out what's one word in the English language that doesn't rhyme with anything. Month. And I was like, oh, you're right. That's weird, but you're right. Yeah. 20 sides. I don't even know that. I'm just making a point. Anything above 12, here's what we're going to do. We're going to say the number of sides and then put a gon with it.
20 gone.
All right, so 20 gon. So anything above 12, that's how we're going to roll. So basically, I have n here, n number of sides, n gon. All right, n just represents any amount of sides. All right, so a couple vocabulary terms about a polygon. A diagonal. Some of you probably know diagonals like this, and you don't have to draw this. Like if I have a quadrilateral here, you guys know corner to corner, right? I got a diagonal. Or I can draw it here, corner to corner. I got a diagonal. But you can have diagonals in all of these figures as well. So what does that look like? Well, let me throw a pentagon up here. A diagonal, a line is considered a diagonal as long as it connects two non-consecutive vertices. So if I start here, that's a diagonal. Okay? If I start here, that's a diagonal. That's a diagonal, as long as I connect two vertices that aren't connected. All right, non-consecutive. Well, Mr. Carlino, what if you connect two vertices that are consecutive? It's called a side. Okay, it's called a side. All right, diagonal's got to connect two non-consecutive vertices. Good. And finally, there's actually two types of polygons: a convex and a concave. Convex, what you have been dealing with your entire life. That's what a convex is. Here's an example of a convex. What makes it convex? Every single diagonal can be drawn inside. Every single diagonal can be drawn inside. Concave, on the other hand, that's not a polygon. That's an arrow. 1, 2, 3, 4, 5, 6, 7. Actually, that's a septagon too. All right, but it's concave. What makes it concave? I can draw at least one diagonal on the outside. I don't know if you see where it is. Two non-consecutive vertices, right? There it is. So if at least one diagonal can be drawn on the outside, we call it concave. If all of them can be drawn on the inside, convex. Convex. All right, so just a couple vocabulary terms. How many degrees are in a triangle again? 180. We didn't know quadrilateral, but now we're going to find out the rest of them. All right, by filling out this chart. So we're going to look at 5 figures. 5 figures, or your group's going to look at 5 figures. A triangle, a quadrilateral. We're also going to look at a pentagon, hexagon, and an octagon. You guys can go ahead, fill in the number of sides because we've already discussed that. All right, what do I mean by the number of triangles that can be formed? Well, first, let's start with the triangle. All right, there's only one there. And what's the sum of the interior angles? 180. Okay, so what do I mean going forward now, the number of triangles? All right, so let me put my quadrilateral back up here. Here's what I mean by number of triangles. You are only allowed to start at one vertex and stay there. And then you draw in as many diagonals as you can from that vertex only. So in a quadrilateral, that's the only diagonal I can draw in. How many triangles did it form? Okay, so now I put a 2 here. And you guys already know, in each of these 2 triangles, how many degrees are there? So I have 180 degrees in this triangle, 180 in this one, for a total of? Okay, there you go. There's 360 degrees in a quadrilateral. And I'm going to let you and your group go on your own now. You're going to draw yourself a pentagon. Start from one vertex only. How many diagonals can I draw? And then how many triangles can be formed? And then find the sum of the interiors. You should get to a point at the end of this, let's say I put number 6 and put a 25 gon. You don't need to draw it out. You should already know how many sides, 25, right? How many triangles it's going to form, and what's the sum of the interior based on the work you just did here. All right, you're going to find a quick pattern. So go ahead, discuss it with your group, draw a pentagon, hexagon, and octagon, and see if you guys can find a little pattern at the end.
Across horizontal.
180 times 3. Four. Yep, 2020. I assume an octagon is going to be 6.
Hexagon 6. Octagon's 8. Oh, look, this goes up.
Yeah, I think it's 6. Were you right? Well, actually, this time it's going to be 180 times 6. $1,080.
And also make sure you find a pattern too. All right, just don't fill it in and we're done. Find a pattern because I don't want to have to keep drawing out this figure and seeing how many triangles are in it anymore. I want to get right to it. Pentagon. Here we go. Let's start with the pentagon. Pentagon here. Lauren, how many triangles were formed?
3.
3. So how many degrees are in every pentagon?
540.
540 degrees in every pentagon. Perfect. Hexagon now. Let's go to hexagon. Alexi, how many triangles were formed? 4. How many degrees in every hexagon? 720 degrees every hexagon. Good. And then finally, octagon. Jonathan, how many triangles? 6. How many degrees in every octagon? 6 triangles. 1,080. Yep. Okay, do we see a pattern? If I give you the number of sides, how can you predict the number of triangles that are formed? What's it look like here? The number of triangles will always be what compared to the number of sides? Discuss that here with me. What do I got here? Finley? 2 less. So if I have a 25 gon, I don't need to draw it. I already know there's going to be 23 triangles formed. Multiply that times 180 and 4,140 degrees in a 25 gon. All right, so all I need to do going forward is, hey, subtract 2 from the number of sides and multiply by 180. Now let's make that official. And our polygon angle sum theorem, this is all this says. The interior angles, or the sum of the interior angles, the sum of the interior angles will always be I'm going to put n minus 2 in parentheses. That gives me the number of triangles. So what do you think n is going to represent here? Now, I got to give you the number of sides, right? Number of sides is n. That gives me the amount of triangles formed. And then what do I still need to do? Multiply by 180 degrees. Okay? So if you ever want to know how many degrees are in a figure, that's the formula we're using. Number of sides minus 2, then multiply it by 180. Good work. All right, 1 more or 2 more quick questions here. 100 sides now, 100 gon. 100 gon. How many degrees are in a 100 gon? So now the value of n is 100. So I do 100 minus 2, multiply it by 180. So 100 gon, which I'm sure has a special name, but Alyssa, when you're ready, how many degrees in 100 gon?
17,640.
Yep. Whew. A lot of degrees. Anything here? One more with the interior angles. Here's just a random polygon. What's the missing angle, right? What's the missing angle? Well, first of all, somebody name this polygon I have up here. It's got a name. All right, it's got a name. What's the name of this polygon we have up here? Ooh, 2-zip here. Brendan, what's the name of this polygon? It's a pentagon, right? Because it's got 5 sides. So you can look back at the chart or recalculate the number of degrees in there, and there's 540. I know 4 out of the 5. And I know they all add up to 540 because it's a pentagon. So that remaining angle, Finley, what's the remaining angle there? 103 degrees. All right, good. So now we know all about the interior. Now it's time to go on the outside. All right, what's the deal with all the exterior angles? All right, what's the deal with all the exterior? So I'm going to divide you guys into 3 groups here in a second. Just let me tell you what I need out of you. 2 jobs. Here's 2 jobs in your group. It's going to take you about a minute or 2. You're going to go to each interior angle and find the exterior. Well, how do you do that? Well, if that's 95 interior and I keep extending one of the sides, what's the relationship between the interior and the exterior next to it? Should be what? Supplementary, right? They should add up to 180. So don't do this. You're not going to have to do this for all the figures. You're going to be assigned a figure in your group here in a second. I want you to find every exterior angle. So this, for instance, group 1 here has got 1, 2, 3, 4, 5 interiors. They're going to have 5 exteriors. So find all 5, and then I want you to add them all up and tell me what they all add up to. All right. So here we go. Group 1, 2, 3. Group 1, group 2. So please just focus on your figure only. Find every exterior angle and add them all up. And make sure you and your group agree on what they all add up to. Okay? So if your group has 5 interior, you should have 5 exterior. 4 interior, 4 exterior. And add them all up at the end. What do all the exterior angles add up to? And make sure you and your group are in agreement before you tell me. So first find each exterior angle and then add them up. Yes, sure. Okay, here we go. Let's see if we see a pattern at all. Group ones, what'd you have? What do they all add up to?
360.
360? Group twos. Oh, the 360 you say. Oh. Group three. Oh. Looks like I don't need a formula like I do for the interior angles, do I? Doesn't matter the number of sides. Does not matter. All exterior angles in any polygon will add up to 360. All right, so the sum of the exterior angles, I don't have a formula for you. You don't need one. I don't care how many sides it has. It's always going to be 360 they add up to. Does not matter number of sides. All the exterior angles will always add up to 360. All right, so what about example 3 then? Find the sum of the exterior angles if it has 36 sides. Dylan, if it has 36 sides, I don't care if I put 3,600 there. Doesn't matter. 36,000. It's equal to 360. Okay, we good with that point there? Interior angles now, I got to go back and use the 180 times n minus 2 formula. But exterior always equal to 360. One last vocabulary term for you. What happens if I'm told the polygon is regular? Regular, which is a lot of the polygons we're going to deal with. If it's regular, first thing I know, all the sides are the same. All sides congruent. All the sides are congruent in a regular polygon. And guess what else is congruent? Angles. And I'm going to get a little bit more specific. All the interior angles are the same. And so are the exterior. Okay? So that telling me I read a problem and see the polygon's regular, perfect. All those interior angles are the same degree measure and all the exteriors are the same degree. So in number 4, I got a regular polygon, 20 sides. 20 sides. All I want is one. What's one exterior and one interior? Okay, I don't want the sum. I just want one exterior and one interior. So I'm going to start with the exterior because I think that's a little easier than the interior. All right, what do they all add up to? 360. I don't care how many sides, right? They all add up to 360, and I know there's 20 of them that are all the same. What do you want me to do with that 360 and 20 then? Divide them out, right? 360 divided by 20 exterior angles that are the same. So we're looking at one of those exterior angles to be 18 degrees, right? 18. You ready for the interior now? What's one interior then? I'm going to go over the tough way, and then I'll go over the quicker way at the end, all right? So I shouldn't say the tougher way. It's the longer way. We knew that all the exteriors added up to 360 and we divided by 20. Can you guys find me what all the interior angles add up to? We got a formula for that, right? We showed you at the beginning of class. Formula for it, 180 times n, which is what here? 20 minus 2. That'll tell me what they all add up to, and then I'll divide that by 20 instead. The exterior was just a little quicker because I know it's always 360. Interior depends on the number of sides. So what? Anybody have that number? What do all the interiors add up to? No. Just all of them. All of them. Anybody get that number? 3,240. Yep. All right. And yes, I divide that by 20 and I get 162 degrees. That was the longer way. How can I get to 162 a little quicker? Remember when we were doing these figures in our groups? Everyone chimed in. What do I know about the interior and the exterior? They're always supplementary. They always add to 180. So to get there a little quicker on this problem, I could have taken my 118 and done 180 minus 18 and still would have gotten 162 degrees. Okay, I don't care how you do it. Okay, but just keep that in mind every single problem that an exterior and interior always add up to 180. Questions I'm finding one of each here. Questions I'm finding one interior and one exterior. All right, next up. How many sides does this figure have if I know one exterior is 120? How many sides? Now, one thing I will not accept in this class because it's an above average math class is guess and check. Well, let me start with 5 sides. Let me do, what's one exterior? Oh, that didn't work. Let's do 6. Let's do 8. That's not going to cut it. I want something mathematically. All right, not guess and check. All right, so if one exterior, exterior. What do they all add up to? 360, right? So I'm going to take 360 and see how many of those 120 degree angles go into it. Because they're all 120 since it's regular. And this tells me there are 3 sides, aka a triangle. And that's where I'm going to stop here. I'm going to make you guys talk to each other in your group to do 6 and 7 because these are a little tricky, 6 and 7. All right, but I think you guys can handle them based on what we talked about today. So go ahead. A few minutes here to end class on 6 and 7. So one interior now is 160. How many sides? No guess and check. But always remember, if you know an interior, you know an exterior. Think of it that way.
Oh, yeah. What are we doing?
Oh.
Talk to each other about it, especially that last one. It's going to get tricky. You got to know.
I'm trying to figure out Polygon.
I know what it says. It says 36 yeah. Oh, 360. Yeah.
So we're given the interior angles, so we can find the exterior angles because they add up to 180. So the interior angle is 160, then the exterior angle is 180 minus 160 is 20. So we divide the total, or the sum of the exterior angles, which is always 360, by one of the exterior angles. And then
Yeah,
right, there's 20 degrees divided by 180.
I don't understand.
Okay, so there's 2,880 degrees total in this polygon.
No, so what you do is divide it 2,880 by 180.
Exactly what I just said. 16, and then 16 plus 2 is 18.
I don't
remember.
Okay,
Did you get 18 sides?
so
18 times 20.
It's 16.
alright, so you have to find the reverse sides.
Oh, then there's 16 triangles. Oh, it's plus 2. It's plus 2. Because there's 16 triangles, and the number of triangles is 2 less than the number of sides. Oh, it's fine. So we just found the number of triangles by doing 2, 8. Oh, so we have to add 2. Yeah, so you add 8. So if you go with 18. Yep. 18 sides.
This math stuff, nothing makes sense.
Okay, let's talk because I see there's still some confusion. Some people are picking it up. That's fine. All right, so for number 6, I'm giving you one interior is 160. If you get stuck tonight on the assignment, think about an exterior angle. Do I know what its exterior angle is? And why do we all love dealing with exterior angles? We know what they all add up to, right? 360. So if there's the interior angle's 160, how do I find the exterior again? 180 minus that. So I know the exterior angle here is 20. And why do we love working with exterior angles? We know what they all add up to. 360 divided by how many 20-degree angles are in 360? 18. So this is an 18-sided figure. Okay, so if you can deal with exterior angles on tonight's homework, deal with them. Deal with them. And then number 7, I heard a lot of good conversation on number 7. I'm giving this number 2,880. It is the sum of the interior angles. You have a formula for that. You created it yourself in your groups today. What's the formula for the sum of the interior angles? What formula do I need here for the sum of the interior angles? Here we go. Drew, what's that formula?
180 times n minus 2.
Yeah. And in this case, it's equal to 2,880. And this is what you, and I heard most groups who knew what was going on here say, hey, I got to divide by 180 and add 2. That's exactly what you do here. Get rid of the 180 by dividing both sides by 180 and adding 2, or maybe some of you the algebra brain works a little bit differently, and instead you want to distribute 180. That's fine too. Okay, that's fine too. But the 2,880 had to get set up to our formula. And no matter how you solved it algebraically, you got 18 sides out here as well. Okay, 18 sides.